But here's the microphone, and I have here on this nice iPad device the online questions that we've received during this event. And as you are Helena, I think, yes, I start from you because you have the microphone. Question, yes, you are the first candidate. You will each get at least one question, so that's my aim. Question to you from the audience. What industries are especially critical in water issues and how could they benefit from water footprint?
Let's say I would say that there are different type of industries that are critical. I mentioned the big industries like forest industry and mining industry. They use a lot of water, so that's why the water footprint and indicator to show where how to decrease the water use, it is important. Then there are industries that like textile industry, they have different kind of so to say critical points in water use. Those who use cotton, cotton needs irrigation quite a lot, so that's different way of using a lot of water. And also, I suppose they have some emissions when dyeing those clothes. And then I would like to mention chemical industry. Of course, they have might have emissions, but they also they are chemical industry which produces and develops chemicals that reduce the emissions and reduce the water use. So that is also, in a way, positively critical issue.
Thank you, Helen.
Yeah. Okay.
Could you pass the mic to Elina, because you are my next target. Question to you regarding water footprint, the development and especially utilization. What are the main challenges? It's not a piece of cake, but could you elaborate on that?
There are major challenges in water footprinting. Well, I think one of the main challenges is that there's a lack of common approach. There are different people talking about all these different kind of terms that are there, and there are different kind of tools and methods, and we really need a common approach so that we all speak the same language. And of course, when you do the water footprint calculation, there's a lot of data that you need to look for, and the data is quite often not so easy to gather, and the difficulty is also that you have these general data banks that you can use, but the information on water use is missing from there too. Yeah, I think those are the two main.
Okay.
Thanks.
Thanks, Elina. And Jani, you are the next one. Okay, when talking about water reuse in industry, what are the main technical bottlenecks or hurdles that should be overcome to enable wider reuse of water?
You couldn't come up with any wider question.
What's the meaning of life?
Well, I say that the technology already exists. There are production sites that have no effluents at all. They only take water in, and only water that goes out with the product or evaporation. But that's again question of optimizing between money and the technology. There are definitely things to improve and technologies to develop. As I mentioned in my presentation, for instance, removal of dissolved substances, that's really expensive because you basically need electricity or evaporation to perform that, and that's expensive, but it can be done. So in that area, a lot of technology are lacking. And also in terms of optimizing, there are some things that are really difficult to measure, and now I mean measure online, because in terms of optimizing the production performance, you really have to know the status of the process all the time. So for instance, issues related to microbial activity are those that are lacking in order to improve the performance in that area.
Just 10 seconds ago, we received a follow-up question. I'll continue with you. Can you give your opinion on what is the most eco-efficient internal purification methods in closed cycle paper mills? Because as you said, the energy is a critical issue, but what are the most efficient ones? What is your opinion?
Yeah, that's again a question of performance. I would say that currently the most used equipment, at least those to be installed in, would be the disc filters used. They are able to give different kind of fractions of the water to be used in different positions of the process, and at the same time they mainly recover all the valuable material from the system. So I would go with that in this stage, but of course that's not the technology that would give the best water quality. If you perform ultrafiltration, it definitely gives more cleaner water for the process, but its performance is, it costs more to install the device and use it.
All right. Let's hope the online audience is satisfied with that answer, or you will get a third one. But
try me.
Could you pass the mic forward? There is a question regarding risk management. After Fukushima, do you think that it will be possible to assess the risk so as to take preemptive measures from a, let's say, from a global point of view? How would you address that?
Ooh, that's a wide scope, but I would say, of course, we can. The aim has to be that we have to kind of react to changes and also aim to kind of see what are the possible risks that are coming, and we have to be kind of proactive in our actions in order to survive, I would say.
All right, thank you. Then a question for our guest speaker. I'm trying to combine a couple of questions here, but there's a specific question regarding cooling waters. So the figures for the water consumption per ton of paper, are they including the cooling water, or is it only water that has been in contact with the process?
It is the water that has been in contact with the process.
Okay, so cooling waters are excluded.
Yes.
How about then a follow-up question of, have you been able to connect the water savings with economic result?
Yes, definitely yes.
Do you have any examples or figures of that?
For example, when you decrease effluent volume, you don't need to use so much money for electricity when you pump the water. So there is synergies between water consumption and energy consumption, etc.
Okay, thank you. Here, I think this question could be answered by anybody. So I'll address it to all of you. It's a kind of an example case. So if a paper mill takes in, for example, like 10 cubic meters of fresh water per ton of product, and then discharges the same amount of treated water at approximately at the same content of dissolved material, so basically it takes in and out, same volume, same level of quality, is it fair for the others, here is said, to claim that this usage has contributed to the water footprint? So opinions on that topic.
Maybe I will give the microphone to Elina.
Well, my first idea that came into my mind was that if you don't really consume water there, if your input is the same as your output, and then if you don't degrade the quality of the water, like, did I understand right that the water, the quality doesn't change? So just out of blue, I would say that you wouldn't have any water footprint. I don't know if what do you say, Helena?
Yeah, well, no, you're actually correct. I just came to my mind if it's the same water source. So that might be only thing that might matter. Yeah.
Any other comments on this question? Can we take a question from the audience? Do you have a second mic? I'll take a question here in between as we are moving the mic in the audience. Here's a question. Let me find it. To Minna Tolonen. How do you control actually natural water cycles in forests? That was an example in one of your slides.
Forest evaporates water, but then it goes back to the natural cycle, comes back to the same forest as rainwater. So there is a natural cycle of the water in the forests.
But do you take active measures of how to control that natural cycle?
One important thing is that, for example, in Finland, forest growth is bigger than what wood is actually used. So there is this circulation going on all the time.
Okay, thank you. Now question from the live audience.
Hello, just maybe more of a comment to the paper mill water footprint case, that although I would say that if the water is not degraded, but if you use it, you would still need to do some kind of impact assessment, because it might be out of reach from somebody else. So there might still be a local impact of this water intake, even though there is no degradation or the water doesn't go anywhere, or it's not. I mean, that you would still need to think about at least the social impacts, because if you are on a water stress area, then it might have an impact on others, even though the water quality doesn't decrease.
I would actually continue. I would like to mention also that the value chain needs to be considered here as well. So if the one process is not consuming or degrading the water, it might be that some other raw materials that are used at that location still contribute to the water impacts.
Thank you. Would you like to continue from that? Well, if not, I will then move to another topic. Reverting to Minna's presentation, and especially this case about the UPM Pietarsaari, here's a question from the online audience. Why is the outlet of water to the Baltic Sea considered as consumption? So meaning if the water is taken from another source, then it's then distributed or exhausted to. What is the reason for that?
It's causing high blue water footprint because it doesn't go to the same water course where it was taken from. So it goes to another water course.
I'm just trying to figure out from a layman's point of view, if the water would go from the river anyhow to the Baltic Sea.
But I mean, that's the methodology question. Yeah. The water itself, it doesn't disappear.
Just to specify that it's not the methodology of the ISO water footprint. It's a methodology of the water footprint network, isn't it? Yes.
Here's also one additional question regarding the UPM water consumption in the pulp mill. We already discussed about these cooling waters, but do the pulp mill water footprint also include sealing waters, and how much of the water footprint comes from the bleaching plant? Can you elaborate on that quite specific question?
Yeah, that's really specific question. The sealing water is normally cooling water also, because it goes to the pump and then it leaves from there uncontaminated to the clear water channel. So that's a part of cooling water. But how much is the bleaching from the total pulp mills or paper mills effluent? It depends so much on the case and the mill, because the mills are so different, so I cannot give any accurate number for that.
Okay, I think our audience is satisfied with that answer. Now a question to all of you. From the audience, we have international agreements on carbon emission reduction and can trade carbon credits between Europe and Australia. Apparently the guy must be from Australia, from 2018. But with regional environmental impacts like water scarcity, will it be possible to have a global approach towards water scarcity, or will it remain always as a regional topic? Will there be like a water credit scheme sometime in the future? Would anyone like to comment on that?
Well, I do not have the actual knowledge about that, but I assume that because it's the global issue anyhow, we are living in the same earth. So in that sense, yes, I hope that there will be someday if it will come critical.
All right. I agree. Then going back to the example with this Pietarsaari UPM mill and with the two different sources of the water supply and output, a continuing question pertaining to the earlier example about water going in and out from the same paper mill with no change. What about the likely temperature increase and salt conductivity increase? Does one need to account for the amount of energy or cost needed to remove salt or cool down the water to match that of the intake water? Quite lengthy question. In the water footprint, I guess the main question here is, do you need to take into account the temperature increase of the water or the salt conductivity increase of the wastewater and an effect of that into the water footprint?
What does Elina say about this grey water footprint?
About temperature, at one point at least, I remember that temperature has been one of the parameters that has an effect on the water footprint. And about salts, of course, that would be changing the quality. So I would say that it has an effect on your water footprint.
I would also comment that it comes through the process as well, because temperature as well as salts change the process water, and at some points it's so contaminated that you cannot use it anymore, and then you have to discard it, and then it has an effect to the footprint, also with the volumes, not only with the quality.
All right, thank you. Switching gears a little bit to Lisa regarding risk management. Again, an easy question to answer. When is risk on an acceptable level?
Okay, risk acceptability depends on the company's risk management policy. So the board of directors or the managers of the company should decide what is the acceptable level. I guess normally the minimal level is considered the level that comes from the legislation, but it can be higher than that.
Okay, and of course it's a question of economical concerns, then how much risk-empty measures you can take.
Yes.
Then switching gears again, moving a bit from the forest industry to the, let's say, other fields, but still remaining within the UPM portfolio. Question to Minna Tolonen, have you calculated water footprint for new tall oil-based biodiesel products?
No, I haven't.
That's an easy question then to ask. All right, thank you. Let's see. Well, then for Jani, one following question. How significant savings can be achieved through process optimization?
Quite general as well. If we take an example, for instance, on variations related to the process optimization. So if you are optimizing process variations, that's probably an easy way to approach it. And of course, it depends what range your variations are. But if some parameter is, for instance, fluctuating with a 2 or 3%, by optimizing it, you are able to reset your target values, and then you can basically save that amount of raw materials, energy, water, electricity, everything. So potential depends on the state of the process, but what case studies we have performed, I would say that it's several percentage in every process and tens of percentage in some processes, only related to variations. But of course you can then switch the raw materials, saving that, switch the chemicals, there's possibility to save there, or increase the product quality and get more price out of your product as well. I won't give you euros or any other currencies.
Okay, I'm satisfied with that answer. At this moment, as we are quarter past, I will close now this question and answer session. I thank all the speakers for your friendly and excellent answers despite the difficult questions. In addition, I would like to thank all our online audience for the staying online and taking the time to join us today. A couple of comments still. First of all the materials, presentations and online recordings will be available online later today. Secondly, if you would like to dig deeper into these topics discussed today, you have the contact details of all the presenters at the end of the presentation. So feel free to contact them if you have further questions or would like to get into discussion with BTT regarding these topics. And thirdly, this is one webinar in a range of BTT webinars, and we will be arranging other seminars during the springtime of 2013 and continuing, of course, after that. So we will be in touch with you later, and we welcome you to join us also in the following events. So now, thank you for everybody for your attention. Thank you for the speakers, and I wish you a nice springtime. Thank you. Bye-bye.